I am here now to share the solution to question 3 for the recently concluded Pure Math 1 Variant 3, uh, May June 2025. Uh, I have received quite a lot of requests for question 3, which is an integration question. So let's just go on with the question. So question 3, given that the integration from 1 until 3 a over 4x minus 3 squared plus 2 dx equals 12, find the value of the constant a. And this is a 4-mark question. So this question is very simple. It's quite direct. You need to be able to integrate, perform the integration, and then set it to equal to 12, and then using algebraic manipulation, make a the subject, and you'll find the value of the constant a. So here the key word here, it says find the value. That means there's only one value of a where this is going to be true. All right. So one of the things that you must notice here is that this is not a power function, right? So usually for P1, the integrals that you have to perform are only for power functions, right? So in this case, this is not a power function. So that means, right, there you must rewrite this in the form of a power function so that you can then use the rule for integration of power functions, right? So we rewrite this part here. This 2 here is fine, but this a over 4x minus 3 squared, we have to rewrite it as in index form. So if we rewrite it in index form, right, this becomes a times 4x minus 3 power negative 2. So now we have a power function. And the other requirement is that inside the power function must be at most a linear function. Okay, only a linear inside a power function you can integrate at least at the P1 level, right? Later on, when you take P3, or some of you might have already taken some P3 syllabus, you will have non-linear functions inside this power function. So you guys don't have to worry about that yet if you're only doing P1 right now. So now if this is in the form of a linear inside a power function, so then we can use the rule for integrating power functions. All right, so go ahead and apply that rule. Make sure you do an equal 12 at the end, because we know the result of this integral must equal 12. So we keep that so that, to remind ourselves that we are going to get 12 in the end. So go ahead and apply the rule for integration of power function. Uh, we have a, right, and then increase the power by 1. Okay, so negative 2 plus 1 becomes negative 1, right, and then divide by that increased power. So when we divide by negative 1, it's the same as multiplying by negative 1, so I put a negative sign in front here. And then you have to differentiate the inside function here, in this case for x minus 3. Differentiate it, it will give you 4, so we have to divide by that 4 as well. Okay, remember this only works if the inside function here is a linear. All right, and then plus, so 2 here is a constant, and the rule for integrating constant, very simple, just multiply with the variable here, x, so 2x. Right, and we're gonna evaluate this integral at the limit 3 and 1. Okay, and the result must equal 12. All right, so let's go ahead and substitute 3 and substitute 1. Okay, and we get this. Okay, be careful while doing substitution. Make sure you put brackets just in case. Um, and I would say though, uh, usually the values that they give you will cause these calculations to be very easy. Right? For example, here if I put 1 in here, right, 4 times 1 is 4, minus 3 is actually 1. So in the end, this value here becomes 1. And so yeah, most of these are meant to be done such that are designed such that you can actually do it without a calculator. Okay. So anyway, just carefully evaluate this, okay? And if you do that, you can get to this point. Usually what I do is, because I have the A's here and the numbers here, right? The integers here, I usually try and collect them together. So when you do that, you'll get this form. So at this point, this looks very easy, very simple. Our aim is to just make A the subject. So you can bring the constant, sorry, the integer plus 4 here to the other side, and you can make this part here single fraction So you have 9a minus a divided by 36 equals 8. It after some simplification you might get a over 9 equals 4, or you may directly get a over 36 equals 1. So whatever the simplification you get, right, if you do it carefully, you will get in the end the final solution, the final answer equals 36. Okay, now here's something extra. Now, one of the things that students might experience in an exam is after they finish all of this work, right, and they get the final answer, they're they're not sure, right, if the answer is correct, right? When you're doing your exercises, right, there's always a way to find out whether your answer is correct, right? You can use a Desmos, right? It's a tool, right? Desmos is a very nice tool, very convenient tool for you guys to check your work. You can have a friend. You can see, for example, if you're doing an exercise from a book, you can look at the answers that are usually listed at the back of the book, right? So you always have to the ability to know whether you have your final answer to be correct, or you can also know if you're wrong. But in an exam, right, one of the ways to know if you're right or wrong is to do it again, do this entire thing again, and if you do get the same answer, you're probably right in the first place. But of course, that's going to waste a lot of time. So if you have a definite integral question like this, right, the best way to check if you have a calculator that can perform definite integral is to actually just go ahead and evaluate that integral, right, using the value that you found. So a checking tip, you can do this really quickly after you get here the value of a. Substitute the value of a that you found in here and just key in that integral into your calculator. Okay, just key in the integral into your calculator, and after pressing equal sign, right, make sure you match it exactly, okay? Match the notation exactly. If you get 12 in your calculator, that means that 36 there is correct. Okay, there's only one way for it to be correct. So if you do get 12, then you know, hey, you're right, right? And so you can proceed with the next question. You can go to the next question knowing that you did everything right in this question. So if you do get the value a equals 36, then you have done a good job.